Hey, how's it going? A little bit of context for what we're working on today. Hello, my name is Dan. Sometimes I repair wheelchairs, sometimes we go on trail runs. It's not every video, it happens quite often, but I live in this little crappy apartment and I get about 4 hours a day that I can actually be in here and work on stuff without wearing earplugs or noise canceling headphones. So as a result of that, I occasionally have to find stuff to do that keeps me from, as I say, going insane. Because sitting in a basically windowless box and just staring at the walls and watching YouTube, well, it gets a little old pretty quick. So I found myself looking around here, trying to find different projects I can work on and other things just to keep myself busy. Now, I use a wheelchair to get around. I do have a spinal cord injury, amongst other things. And as time goes on, things get more and more difficult. Of course, everything is kind of a mental battle. So again, the idea is finding things to do to keep busy. As you can see, there's a lot of stuff in here. I work on a lot of things, and it's a little tricky to repair wheelchairs sometimes when you don't have a shop to do it on, so your living room kind of becomes that. And I was realizing that I've got a cart full of batteries and a power inverter that we used for the v2.0 battery testing, doing all the data logging and stuff. And then I've also got this crazy big toolbox on wheels. Now where I live, the power grid's not super reliable, so I have some EcoFlow battery banks and a few other things like that. But I realized that cart's wasting space and this toolbox is sitting here unused. So the project for today is we're gonna combine the two things. That way I've got a little bit more storage. It's something cool to work on because building stuff helps your mental state and keeps your brain occupied, and there's a sense of accomplishment when you're done. So anyways, let's look at this stuff, see what we can put together, and hopefully come up with something kind of cool.
Here we go.
We have this closet filled with stuff here, and buried under this Blu-ray player, we have a cart that I built. Well, this originally was set up for the v2.0 battery testing, where we stick some Permobil branded batteries on here, and then we had current monitoring with this little guy here. Anyways, that thing is taking up this cart, and I would like to consolidate that into something else that's a little bit more portable. If we go out here into the kitchen, we have this rigid tool cart stacking thing with wheels here, and that is plenty big to stick at least one set of batteries in and mount an inverter on top of. This whole stack of stuff is literally just to hold this, and it's kind of wasting space. So anyways, the plan for today is we're gonna pull this out of here, we're gonna get the batteries in there, we're gonna mount up that 24-volt inverter and try to make this into like a portable power station thing. But you can see here, it's got some pretty decent tires on the back. There's a collapsible handle, which kind of goes up and down, and I actually found this thing in a dumpster, so I think it'd be a good use for that. How does this work? Ah, there we go. All right, now that the washing machine is done with its irritating sounds, we have this, as you can see, basically just a big open thing. I think we should have just enough room to stick a couple of batteries in there. I'm just remembering now, I think these were two batteries that I tried to recover from one of those M300s that I got not too long ago. Oh. That one shows nothing, not even powering on the meter. Well, there you go. Apparently, this one does have an X on it. Maybe that means something. Let's do a quick measurement here. So we've got about 10.5 inches. And, oh, looks like that might actually be a super perfect fit. Yeah, looks like our batteries should fit perfectly in here. I'm gonna grab one and see if it'll fit actually. Okay, that is so perfect. It's not even funny. By the way, these are some Black Label MK AGM batteries. I believe they're the air quote non-gel variants, but you can see they just perfectly fit in there. And press them against the side. So all we're gonna have to do here, I think, yeah, I'll just put the other one in here. Then I'll have to consult my lumber yard over there. And I think we'll just be able to put a couple pieces of wood in here to keep them from sliding around. And I think that should work. Awesome. Yeah, I've got a collection of random lumbery things over here. Some pieces of 2x6s and some of this dadoed 1x2s or whatever. Man, I love it when a plan comes together. Look at that. Let's just fit perfectly in there. And I think these, yeah, those are a little wide. But I think just a regular 2x4 down here should shim that side. Oh, next question. How hard is this going to be to move? Let me get my toes right against this and see. Oh, okay. That might be more weight than it's rated for. I'm having to push down really hard to keep it from tipping over, but I think, I mean, portable enough. We don't need to move it around a whole bunch. I kind of moved the batteries around a little bit and they just perfectly fit like this. And I can drop one of those boards on each side. So I think that's going to work. I won't even need to strap them down or anything. Now, obviously, you don't typically want to have batteries in a completely sealed container, especially when you're charging them. And this toolbox, as you can see, has an O-ring, and it was designed to be completely watertight. These are sealed AGM batteries. However, what I'm going to do is just drill a few ventilation holes in this. That way we just don't have any sort of gas or anything building up in there. Front of this does bow out a little bit, but when I put the lid on, it kind of straightens it out. Anyways, let's do some sanity checking. I've got the handle down all the way. Let's just kind of set this lid on here, like so. Then I think we're going to use this secondary toolbox here. And that latches into place. You can hook these metal things on. But the cool thing is, with the handle down all the way, you can open the lid on this one. Obviously this one's water sealed as well, so we're gonna have to do some ventilation. I went ahead and pulled the power inverter off that card over there. This is just a little like 600 watt, 24 volt one. Not sure the quality or anything. I'm not planning on using this system unattended by any stretch of the imagination, but it does appear to fit in here. And yeah, it looks like we've got some clearance here, so the lid can be closed with that in. We have our outputs over here. Yeah, I think this is gonna work out nicely. I don't really have a use for this sort of toolbox. It's big and heavy and designed to haul around a bunch of weight. And I think this is a perfect application for it. It can just kind of sit back over there where it was until I need to use it. But we're gonna use an XLR connector so we can charge this with a wheelchair. We're gonna have to run our power cables up from the lower part to the upper part. Regardless, I do wanna get this little battery current monitor set up on there. And then this is what we're gonna use for charging. This is a female XLR, so we can have that hanging out somewhere and just use a standard wheelchair charger. But I definitely wanna get this current monitor and this screen integrated in there so we can keep an eye on our voltage and whatnot. But yeah, I think this is gonna work out nicely. Okay, so I'm kind of changing my mind here, but we've got the circuit breaker here on the front, and this is going to be for circuit protection and turning the unit on and off. Now, we're going to have the other box stacked on top of this as well as the lid, so we're going to have some height. And these cables will be long enough to get up to the inverter, but it's going to be a kind of a tight stretch when we're pulling from the outside edges here. So what I decided to do instead is we're going to use these outside terminals on the batteries for our series connection, and then we'll just pull our outputs right off the middle here. And that should prevent any sort of issues with cable length getting up into the top half. You can see here, those are just going to go to the outside edges, and then these will be our outputs here. And when this is off, we won't have any output from these because they're not connected together. So I think this is going to be a much easier way of dealing with things. And It'll allow my cable routing to be a little bit easier once we get up into the top where the power inverter is going to be. And then it'll be nice having our circuit protection here on the outside. Just kind of test fitting here. So that goes on top. And then we have to figure out where we want the wires to go through. So the bottom of this is pretty much flat. And I think for ease of use, or ease of passing the wires through, we should probably go through one of these parts instead of down here. Just trying to figure out the process for feeding the wires. So that's gonna be stacked on there. And then, yeah, I can just open this a little bit, reach through here. Oh, we've got, oh, there's a grid in there. So yeah, I can just reach through here and pass the wires through into the top. And we can have them pop out somewhere over here, I think. I'm gonna have the inverter kind of shifted over to this side and our connections will be here in the back. So yeah, I think that'll work, somewhere in this general vicinity. I think I'll just kind of arbitrarily pick a spot right here and run a hole there. Oh, that is some thick plastic. There we go. We got 1 and 2. And now our wires pop up right there. Perfect. All right, this is coming together nicely. There we go. It is now mounted. Moving back to mounting our cables. I'm pretty sure this switch is off, but let's do something dangerous and double check. Okay, yeah, it's off. I think I'm gonna go ahead and get our charging circuit and all the current monitoring and everything will be in that upper box. This lower area I want to just kind of only be batteries and nothing else. Let's get our wires put through the lid here. All right, bottom part should be good to go. Let's get the top half over here. Get our wires passed through. And lower our handle. Okay, we've got wires coming up through here. I'm gonna do a little bit of screwing around and see about laying out the battery monitor. It would be kind of cool to have it visible from the outside. So maybe I could cut a hole here and have the display visible. I mean, the handle's not in the way. Anyways, I'm gonna do some looking around, see what I figure out, and I will be back to update you momentarily. Okay, that turned out fantastically. Oh, we should probably peel off the little covering that's on there. Yeah, we'll do that when we're done. Look at that. I have not mounted a control panel in forever. That's sweet. All right, been working away here. We've got the control panel plugged in, and that is now hooked up. Got a terminal block over here. Turns out I don't have any drill bits that are big enough or hole saws for this. I was thinking it'd be cool to have the USB charger right there next to that, but not gonna be able to do that today. But regardless, I've got a terminal block over here, and that's gonna be used for connecting the wheelchair charging port. I'll probably put that somewhere on the outside edge. But we've got our current shunt set up over here, and everything should be ready to go. Like, I think I'm gonna hit the switch and see what happens. Pretty sure everything's wired correctly. Only one way to find out. Feel like something should have lit up when I did that. Okay, well, the inverter's coming online. I'm not sure why this isn't coming up. All right, well, that's a strange problem I've never had before. Somehow, both of the crimps that I made to connect the power from this thing to here were bad. I have no idea how that happened, but anyways, it's working now. Turn this on. We get our little display here, and I'm gonna have to program how many amp hours we have in the batteries and whatnot, but if we turn on the inverter here, should be able to see we're getting a little bit of a reading. It's about 600 milliamps being pulled out of there right now. I was sitting here trying to figure out how to install this. Then I remembered I have a secret weapon. Step drill bits. These will work perfectly for this. I was gonna put it over here. Actually, hang on. It came with some wiring. You know what, that's long enough. I'm gonna put it over here. I want it to be on the opposite side of these buttons, so I'll just kind of hold these wires out of the way and we can put it right about here. Hey, there we go. All right. USB charging. Look at that. Actually, while we're here, let's go ahead and peel off our cover on that. Oh yeah. This came in a little kit and it comes with, there's a dust cover, some connectors, and a fuse. So yeah, it's a handy little thing. I'll link this down below. Amazon associate link, of course. Let me get this wired up real quick. The little dust cover that it comes with is pretty obnoxious to get in and out of there, so we're just not going to use that. And surprise, surprise, it also has a voltmeter. So I'm not sure which one to trust. That says 25.8 and this is 25.4. As I recall, I think this one was a little bit low, but it is adjustable. This one claims 25.42 and that's 25.45, and this is running on some, like, is it 24 gauge wire, so it's pretty small. But yeah, that seems to be accurate, so we'll just ignore that one. Yeah, seems to work. We got the inverter and little power switch here on the front. Should shut it down. Cool. I'm gonna get some of this stuff cleaned up here and we're going to see about doing some load testing and seeing what our current pull is at around, I don't know, 300 watts or so, I think is the most we're probably ever gonna pull on this. Got stuff kind of laid out in here. This has a cover that goes over it. We're gonna add the charging block to that at some point. And display, there's our charger. Everything has so many fuses on everything, so we're not gonna have to worry about that at least. But yeah, obviously when you're running the inverter, you won't want the lid closed. I thought about cutting a hole so I could pass cords through, but I think I'm not gonna do that because if you have this plugged into power, you want airflow in here. And if this does get not closed, the cord will keep it open just enough for airflow to continue. But yeah, I think this is a great starting point. Okay, well, I've got a little 300 watt AC space heater somewhere. I cannot find the stupid thing. I've been organizing recently, so I'm sure it's around here somewhere, but that's what I use for testing inverters and stuff. Regardless, I am kind of curious here. The way this is wired up, the amperage draw from the USB should be registering on here. So I want to plug this little load in and see if we get anything showing up on the screen. Obviously, because that's running on 24 volts, it's the amperage is not going to be, you know, super high, but we should be able to see something, I think. We'll go 1.3 amps, that's standard cell phone draw. And yeah, I don't think much is going to register on here. Let's crank this up here a bit. Oh, there we go. I think the minimum this can register is like 600 milliamps. I'm not sure how accurate it's going to be at that low amount of current, but 2.3 amps, 0.7. Yeah, so it's definitely registering. Turn this back down. Yeah, it looks like 600 milliamps is the minimum that thing can show, but that's definitely working. And if we turn on the inverter, I don't know if I caught that on camera, but it spiked up a little bit while the capacitors were charging in there. Let me find something to plug into that real quick. Yeah, we're just gonna use one of these Volt Pro chargers here. it's set to compatibility mode. I'm gonna plug it into my chair. Let me plug this in. And for about 600 milliamps. Let's plug this into my chair. And that should click on. And ramping up there. Okay, so that's about 15 amps. And you can definitely, wait, what is, oh, I heard some buzzing, but I've got headphones on right now. That's just interference from that. But anyways, 14 amps. And I don't think this shows power output. But yeah, seems to be working fine. Voltage dropped down a little bit. Chair's definitely charging. All right, sweet. Well, I think we have a thing. For now, this is gonna work. I'm gonna get one of the panel mount XLR connectors because I wanna just be able to, well, obviously not charge it with the inverter. That's how you create ground loops and set things on fire. But the idea is to put an XLR jack somewhere on this thing and we can just use a wheelchair charger to charge it back up. Yeah, I think this is a pretty good use of stuff I had lying around. Obviously, this is a nice toolbox and we kind of like ruined it, but I've had this for a year and a half and I've never used it for anything. And that other cart over there is taking up a bunch of space. I'd rather use that for other things. So yeah, it seems to work out pretty well. I am pleased with the results. So after trolling around on Amazon for a little bit and trying to find a panel mount female XLR, turns out Amazon doesn't have the ones I like. They're a much larger metal faceplate that you can screw on. So in the meanwhile, I just wired up this thing. This is a knockoff Nutric, but I've been using these on a bunch of Victron chargers and they work extremely well. So we at least have this on here for now so that I can charge this thing. So let's go ahead and plug in the charger here. And you can see that clicked on and we should get charging amperage here. Yeah, there you go. You can see we're charging at 9.9 amps. Yeah, even though that thing's in compatibility mode, it still outputs 10 amps. And here it is from the back. You can see it's designed to haul a bunch of weight. The cool thing about having the inverter and everything up here is this handle goes down low enough so the cover will actually open. But press that, lifts up all the way, and then, well, I don't have shoes on at the moment, but normally I would stick my toes up against the back of that, and then I could tilt it back and roll it around and stuff. But yeah, not too bad for a dumpster find. I think I mentioned before, but this thing is programmable. I just have it arbitrarily set to, I think, 85 amp hours right now. Yeah, I set it to 85 amp hours of capacity. That's obviously not what these batteries have, but you can adjust that, and then that allows your battery gauge to show a percentage. It's a little hard with lead acid batteries to determine, you know, their actual state of charge, but current monitoring is about as close as you're gonna get. So I'll have to do some testing and figure out, probably closer to 65 amp hours would be more accurate for these. Oh, and another nice thing with this gauge, you can see our voltage is dropping a little bit. That's because I had it charging. So the batteries are slowly equalizing, but because no amperage is actually going out of it, our gauge still stays at 100%, even though our voltage is dropping. So this is about as accurate as you can get for measuring state of charge on lead acid batteries. But anyways, there we go. We're gonna call that good for now. We have a portable inverter slash phone charger slash power pack. I've got, oh, that's right. I was gonna add some of the 12 volt cigarette lighter style plugs at some point too, but I don't know where those are. Regardless, this is a good platform to start with. And honestly, I can probably stick it back over there in the kitchen where it was before and it'll be out of the way and ready to use whenever we need it.